Good evening. Good evening, everyone. Hope your preparation is going on very well for GATE and ESC exam. Today, we are observing few models related to numerical type and multiple selective questions for GATE as well as ESC related to signals and system subject. So, let us see the first question. What is the value of this integral that varies from minus 4 to 2 cos 2 pi t into del of 2t plus 1? Integral has impulse function, that is indication of shifting property of impulse. Integral t1 to t2 xt into del of t minus t naught means x of t naught shift should lie within the limits, but this impulse is not in normal form, scaled form. So, we need another property of impulse. Del of at plus b can be written as 1 by mod a del of t plus b by a. So, try to convert the scaled form of impulse to normal form. So, this can be written as del of 2 into t plus half minus 4 to 2 cos of 2 pi t, that function as it is, del of a into t plus b by del of at plus b, that can be written as 1 by mod a del of t plus b by. So, what is the shift value? T naught, t minus t naught form, t naught is minus half. T minus t naught form, t naught is minus half. Minus 4 to 2 are the integration limits which are including this. So, our result is 1 by 2 cos of 2 pi into minus half. Substitute the instant there. Cos pi is minus 1, cos pi is minus 1. Extra 1 by 2 is there, result is minus 0.5. Application of sampling or shifting property, additionally scaling property of continuous impulse, scaling property. The next example is the fundamental period of a discrete signal minus 1 whole power n plus j power n plus cos pi n by 3. When the three signals are individually periodic, we can observe the common fundamental period, or first we have to obtain the frequency by using GCD logic. Minus 1 whole power n is nothing but alternation of impulses, that is a graph of minus 1 whole power n. For even index it is plus 1, odd index it is minus 1. So, for this function you can feel the time period is 2 samples. We have repetition for every 2 samples, plus 1 minus 1 plus 1 minus 1 like that. We have j power n, j for imaginary, that can be adjusted as e power j pi by 2 n. For checking periodicity of discrete sinusoids, standard condition we have to hold is omega naught by 2 pi, ratio must be a rational number. J can be adjusted as e power j pi by 2 cos 90 plus j sin 90, that is pi by 2 pi pi by 2 by, so it is rational number. Anyway, let us treat this as second frequency pi by 2. First signal -1 whole power n is pi, this is pi by 2. This cos function third frequency is pi by 3. We are having three frequencies here, pi by 2, pi by 2, pi by 3. How to obtain the fundamental frequency? GCD of pi comma pi by 2 comma pi by 3. So we need some adjustment because our concept is harmonics. N into omega naught logic we are following. So we need some adjustment here. The common multiplier, 2 3s are 6. Let us adjust 6. Pi can be written as 6 pi by 6. Pi by 2 can be written as 3 pi by 6. Pi by 3 can be written as 2 pi by 6. So what is the common frequency that is visible for us? 6th harmonic, 3rd harmonic, 2nd harmonic. So time period is 2 pi by omega naught, that is 12 samples. 2 pi by omega naught, that is 12 samples. Very good, Aman. Mr. Satyam, that is a standard condition. Omega naught by 2 pi ratio must be a rational number. That is a standard form we are selecting. So the three individual frequencies are pi by 2, pi by 3. Find out the GCD. Time period is 2 pi by omega naught. For checking the periodicity of discrete sinusoids individually, discrete sinusoids, standard condition we have to satisfy is omega naught by 2 pi ratio must be a rational number, m by n form. N is the time period of the respective signal. As it is sum of signals, we can follow this direct logic, GCD of the given frequencies. Which of the following system properties are true with input xn, output yn? So what is the first expression given? Yn minus 2n into y of n minus 1 equals to xn is linear time varying. Of course, it is a variant system because for y of n minus 1 the multiplier is n. Coefficient is external function of time. Coefficient is external function of time. It is linear time variant, that is true. Linear time variant. What is the second expression? Yn minus 2 into y of n minus 1 equals to 2 power xn into xn is linear, that is wrong. It is a non-linear because it is like unknown signal product 2 power xn into xn, that is non-linear. Coefficients are fixed, time invariant. All the coefficients are fixed here. What is the third expression? Y of n plus 1 minus yn equals to x of n plus 1 is non-causal and static. To avoid confusion, let us assume n plus 1 as m, such that what will happen to this expression? Y of m minus y of m minus 1 equals to x of m. M is the present value, m minus 1 is past. Again here m is present value, it is causal. Dynamic. M is the present instant, m minus 1 is the past instant. To avoid confusion, let us assume n plus 1 as m, such that the expression changes to ym minus y of m minus 1 is x of m. It is causal dynamic. Last one, y of n equals to 2 into n plus 1 into xn. Present output depends on present input at the same time is causal. Instantaneous means static system. For a static system, output and input instants must be same. Input and output are observed at the same instant. So, A and D are true. Non-causal means depends on future values. If you are choosing your instant like n, it depends on n plus 1, n plus 2 is non-causal system. Present output depending on future instants. Consider an LTI system with impulse response Hn equals to un step sequence. Which of the following statement these are false? Which of the given statements are false? That is the question. What is the first one? Causal and stable. For causality of LTI system, our standard requirement is Hn is 0 for n less than 0. Because it is given as un, of course covers positive index, causal. It covers positive index, that is causal. Stability. What is stability of LTI system? Standard requirement. Absolute area under impulse response must be finite. Sigma mod Hn must be finite. But in this particular case, our impulse response covers from 0 to infinity with amplitude of 1. 1 plus 1 plus 1 added infinite times. 1 added infinite times means answer is infinity. System is unstable. So, causal and unstable is its nature, but option A it is stated as causal and stable. Causal and, so this is false. B, it is stated that the input and output relation of the system is given by yn equals to sigma xk. Y of n equals to sigma x of k. Let us see. Y of n equals to sigma minus infinity to n x of k, that is an accumulator. When you solve its Z transform accumulation property, yz is xz by 1 minus z inverse. So, the transfer function yz by xz is 1 by 1 minus z inverse, which is actually Z transform of u of n, u of n. Take Z transform for accumulator, that is xz by 1 minus z inverse. Then you obtain the transfer function, take inverse Z transform. That is one way. Other way, if the input is impulse, output is called as impulse response. So, what happens to that expression? H of n equals to sigma minus infinity to n del of k. Sum of impulses is nothing but un, standard relation. So, option B is a true. What is option C? The difference equation describing this system is, same expression can be written as this way. Let us observe how it is true. Now we are discussing about option C. yz by xz is 1 by 1 minus z inverse. So, if I cross multiply yz minus z inverse yz equals to x of z. What is the inverse z transform of this one? Yn minus y of n minus 1 equals to x of n. Same accumulator can be also represented as this difference equation. Cross multiply yz means yn, z inverse yz means one sample shift equals to xn. That means option C is also the inverse of the system is inverse of h of n. He wants to name that as gn is un minus u of n minus 1. Let us verify that. Option D, he has mentioned inverse of original system as un minus u of n minus 1. So, we are aware hn convolved h inverse of n is del n. So, when you apply z transform, hz into h inverse of z equals to 1, convolution converted to multiplication. So, what is h inverse of z here? 1 by hz. So, opposite to this, 1 by this means 1 minus z inverse. If I write the inverse here, for 1 it is del n, for z inverse it is del of n minus 1. Recollect, del of n z transform is 1, del of n minus n naught z transform is z power minus n naught. This only he mentioned in the option D as gn symbol, inverse of the system. So, we got inverse as del n minus del of n minus 1, but what is given in the option? Un minus u of, so it is false. So, the question is, which of the given statements are false? Okay. Very good. Satyam, good. Which of the given statements are false? We got the original system as causal and unstable, but here it is stated as causal and stable. The same expression can be written by in terms of y and xn like this, like a accumulator. How it is correct that we verified it two ways, means second expression is true, means second statement. Third statement also true, we got this difference equation. Last statement false because we got the result as del n minus del of n minus 1, but he is saying this indirectly, gn is simply del n. What is un minus u of n minus 1? That is del n. He is saying that it is simply del n. Okay. This is one standard favorite model for all competitive exam fellows. An input signal x of n is set of 2504 is passed through an LTI system having impulse response hn, producing the output as set of samples. Find h of n at n equals to 1. It is like ordinary convolution example. You are aware when the input length is m number of samples, system length is n number of samples, length of the output is m plus n minus 1 samples. So, when you see the question, input is there for 4 samples 2504, output 4 and extra 2 means total 6 samples, length of the output 822, 1131, 412. Okay. So, input length is 4, output length m plus by n minus 1 is 6. So, compulsory length of the system must be how much? 3. 4 plus 3 minus 1. So, Input data 2504, system is unknown, but what is the length of the system we know. It should contain 3 samples. Let us assume like ABC. Let us assume like ABC. Take the product 2A, 5A, 0, 4A, then 2B, 5B, 0, 4B, then 2C, 5C, 0. What are the output numbers given for us? What are the output numbers given for us? 8, 22, 22, 11, 31, 4 and 12. Just do comparison, we will know the result. 2A equals to 8, that means A is 4. 4C equals to 12, that means C is 3. 4B equals to 4, that means B equals to 1. Therefore, H of n result is ABC. Set of ABC means 4, 1, 3. But where the answer is expected? He wants the answer for H of n at n equals to 1 is how much? Mr. Aman, that is what I said na. Un is not absolutely summable. So in the option he has stated that as causal and stable, but it is unstable. We want the result at H of n at n equals to 1. Input has 4 samples, output has 6 samples. So length of the system in this particular example is 3, which are unknown. Assume them as ABC. Follow sum by column method, do comparison, we will get the result. Okay. Which of the following properties are true about convolution? Some properties are mentioned. Which of the given properties are true, that we have to check. Let us check one by one. Xn convolved Hn into Gn is equivalent to Xn convolved Hn into Gn. That is what mentioned. Option A. Xn. The star denotes convolution. Xn convolved Hn into Gn is Xn convolved Hn into G of n. Let us verify. For convenience, assume Gn as a del n. So, Xn convolved Hn into del n. I am assuming Gn as del n. This is indicating product property of impulse. This is indicating product property of impulse. What is that? Hn into del n can be written as H0 into del n. H0 is some number, H0 into del n. And we are aware Xn convolved del n is simply Xn. Any signal convolved by impulse replicates the signal. Xn convolved del n is simply Xn. Here we used product property of impulse. Impulse exists at 0. Take the value at 0, n place 0, H0 into del n. Xn convolved del n is of course Xn. That is a left side expression. What is the right side expression given? Xn convolved H of n into del n. Gn what we are assuming? Indirectly, this result we have to check at origin. Xn convolved Hn observed at n equals to 0. What is the left side answer we got? H0 xn, left side expression answer. What is the right side expression answer we got? Xn convolved Hn at origin, means they are not equal. They are not equal. False. Of course, option B is true. You know that property, scaling property. When you want to scale the input system by same factor, respect to output is scaled by alpha with amplitude scaling of 1 by mod alpha. In our case it is 2. Alpha number is 2, that 1 by 2 multiplied this side. This 1 by 2 tag is multiplied this side. It is a scaling property. It is a scaling property. Okay. What is the third statement given here? If xt and h of t are odd signals, then the convolution of them is an even signal. This is also a standard property. Convolution of two odd signals is even signal. Let me verify clearly for you. We are discussing about third one. Yt is xt convolved ht. What he stated, xt and h of t are odd signals. What is odd signal requirement? xt equals to minus x of minus t. Similarly, ht equals to minus h of. What happens if I replace t as minus t here? Y minus t is x minus t convolved h minus t. But xt is odd signal, means I can write x minus t as what? Minus xt convolved with h of minus t can be written as minus into minus becomes plus, that becomes xt convolved ht, which is simply y of t. Y minus t equals to y of t means even. Y minus t equals to y of t means it is satisfying evenness. That is what stated. Convolution of two odd signals is an even. So that is true. That is true. Last one you have to observe carefully. If yt is xt convolved h of t, then that fellow is saying even part of yt equals to xt convolved even part of ht plus even part of xt convolved h of t. Let us observe. Let us verify. So let us assume xt as a del of t minus 1 and h of t as a del of t plus 1. So what is yt result? xt convolved ht means del of t minus 1 convolved del of t plus 1. Your answer is simply del t. Okay. So what is even part of yt? Impulse itself is an even function, so del minus t is del t. Then we have to obtain xt convolved het, x of t as it is convolved with even part of h of t. What is x of t here? Del of t minus 1. Everyone recollect what is even signal definition? Signal plus folded version by 2. So that is del of t plus 1 del of t minus 1 by 2. That is producing the result as del t plus del of t minus 2 by 2. That is one segment. What is the other segment we have? xct convolved ht. Means you have to pick the even part of this one. That is del of t minus 1 plus del of t plus 1 by 2, which is convolved with h of t, means del of, that will make result as del t plus del of t plus. Just observe the board. We got even part of yt as this. That fellow is saying sum of these two is equal to even part of yt, which is failure. When you add these two results, it is not equal to even part of y of t. That means fourth option is false. What is the question? True. Which are true here? B and C. B is straightforward. C explanation I have given here. By assuming xt and h of t as odd signals, we proved that the convolution of two odd signals is even. Option D. Even part of y of t is not equals to sum of these two, because we got a different result. Yes, Mr. Raman. Our standard signals are impulse and step, always go with them. It becomes very easy for you. Let us see this model. For the periodic signal shown below, what is the average value of derivative of xt? He is not expecting average value of original signal, derivative of xt. Generally, what is average value definition? Area of the signal over one period by fundamental period. Area of the signal over one period by fundamental period. But when we differentiate this function, which is actually even signal, our original signal is even signal. So, differentiation of this portion, positive step, 0 to 1 negative step, like that the repetition occurs. That is looking like odd signal. That is looking like odd signal, for which DCR average value is 0. Area under odd signal is generally, he wants the average value of differentiated signal. He wants the average value of differentiated signal. Which is looking like odd signal. The signal is odd. Area under odd signal is 0. A signal, continuous signal is given, 4 sin 72 pi t is sampled at 128 Hz, having its discrete Fourier series coefficient as Ck, value of magnitude of C23, value of magnitude of C23. So, first you have to convert the continuous signal to discrete signal. What is the sampling rate stated? 128. T equals to NTS, do that conversion. TS is 1 over Fs. TS is 1 over. 8 9s are 72, 8 16s are 128. So, 9 pi by 16. 9 pi by 16. When you check the time period again, discrete signal means omega naught by 2 pi ratio. 9 pi by 16 by 2 pi, that becomes 9 by 32 m by n form. Here you have periodicity of 32 samples. Here we have periodicity of 32 samples. So, he is asking magnitude of C23. He is asking magnitude of C23. How to write the discrete Fourier series standard form? X of n equals to sigma k equals to 0 to n minus 1 ck e power jk omega naught n. X of n equals to sigma k equals to 0 to n minus 1 ck e power j omega naught n. As the time period is 32, I can take the fundamental frequency as pi by 16. Okay. So, how to expand this? 4 by 2j e power j 9 into pi by 16 into n, one term, minus 4 by 2j e power j minus 9 into pi by 16 into n, that is another term. We are adjusting like ck e power jk omega naught n form. Here k value 9, here k value minus 9. K value 9, k value minus 9. Fixed fundamental frequency of pi by 16. He is expecting for C23, we are aware discrete Fourier series satisfies this property ck equals to ck plus n. Ck equals to ck plus. In this example, what is n value? 32. Means I can write C suffix minus 9 as C suffix minus 9 plus 32, that is C23. That result is minus 4 by 2j by comparison. C suffix minus 9 is equivalent to C23. Anyway, magnitude is asked. Anyway, magnitude is asked. Simply magnitude is asked. Answer is don't forget to use this additional property. Recent time examinations, you got on this property, periodicity property. Based on periodicity property, wantedly they will ask outside the harmonic range, because generally we will say k varies from 0 to n minus 1, but that periodically repeats. That periodically repeats for every Kaplan samples. Let us observe this model. Consider the discrete time signal x of n equals to 3 cos pi n by 2 plus 4 cos pi n by 4 having the discrete Fourier series coefficient ck. Which of the given statements are true? First option he stated that it is non-periodic. Second option he stated it is periodic with a period of 8. Let us verify that point. How to observe the common period of the signal? Simply select GCD of the numbers. What is the GCD of pi by 2, pi by 4? Greatest common divisor. First one can be adjusted as simply 2 pi by 4. So, that will have periodicity of 8 samples. 2 pi by 4. Okay. So, it is periodic. It is periodic. He is saying discrete Fourier series coefficient C9 equals to 2. This point we have to verify. Discrete Fourier series coefficient. So, like we have done in the previous slide, try to write the discrete Fourier series representation of the signal. So, what is the expansion of this? What is the expansion? By clearly showing the fundamental frequency cos 3 by 2 e power j 2 into pi by 4 into n 3 by 2 e power j minus 2 into pi by 4 into, I am expressing very clearly in the form of sigma 0 to n minus 1 ck e power jk omega naught n. We are trying to express clearly in that form. What about the second term? 4 by 2 e power j 1 into pi by 4 into n. Another term 4 by 2 e power j minus 1 into pi by 4 into n. So, in comparison with the original expression, what harmonics are possible here? This is plus 2, this is minus 2, this is plus 1, this is minus 1. So, indirectly you can say first harmonic and second harmonic are possible. But what is the build-up of examiner? He is saying C9. Verify again periodicity, Ck is Ck plus 8. We have periodicity of 8 samples. I can write C1 as C1 plus 8, which is C9. What is C1? Neatly visible. Answer is 2. Answer is correct or not? After expansion, only first and second harmonics are visible for us, but wantedly higher harmonic number is given. Ck equals to Ck plus n. Power in the signal is 25 by 2 watts. How to get power in the sinusoid? A cos or A sin function. A square by 2 is standard relation. Get that. What is there? First one 3 square by 2 plus 4 square by 2 watts. Uh, 25 by 2, 9 by 2 plus 8. So, which are true? He is expecting true. 3 statements are true. Never forget this additional property of discrete Fourier series. Last 5 to 6 years gate paper, maximum number of questions are concentrated on that property. Ck is Ck plus n. Based on that, we are getting models. So, by observation, we can say only first and second harmonics are there. But here we have to use that extra property, Ck equals to Ck plus n. Yeah, Satvik, if you want, you can use Parseval's, no problem. But that will increase your maths unnecessarily. Sigma k equals to 0 to n minus 1 mod Ck square. Sinusoid, na? Directly you can write. That is also correct, sir. Let us try this model. A continuous signal is given. Which of the given statements are true? He is saying xt has fundamental frequency pi by 12. It is periodic, like that. Different statements are given. Again, sum of signals, our logic is GCD of pi by 3 and pi by 4, that becomes pi by 12. 3 4s are 12, because I can write this as 4 into pi by 12, whereas this number as 3 into pi by. We have fourth and third harmonics. So, of course, it has fundamental frequency of pi by 2, true. It is periodic, true. That fellow is saying if xt is periodic having exponential Fourier series coefficient as ak, the only non-zero Fourier series coefficients are a1, a minus 1. That is wrong. Why? We are saying it has fourth and fifth harmonic. This is continuous Fourier series cosine. What is the standard form? Summation range differs. Sigma minus infinity to infinity, ak e power jk omega naught. We have third and fourth harmonics in the cosine. Third and fourth. But that fellow is saying a1, a minus 1, sir. xt has 0 DC component. Do you have any DC? Any additional number that is there? No. It is periodic, fundamental frequency pi by 12. But we have third and fourth harmonics. He is saying only plus or minus 1. First harmonic is possible. When you are solving MSQs, fundamentals are needed related to each topic. Okay. An input signal x of t equals to 4 plus cos 4 pi t minus sin 8 pi t. We want to pass through the system, which is sinc t into cos 8 pi t. Then what is the output of the system? Okay. Normally, sinc t expansion is sin pi t by pi t, that is also stated in the question, which is a rectangular spectrum from minus pi to pi. Let me name for understanding purpose that as h1t. So h of t is nothing but h1t cos 8 pi t, which is our modulation property. I am assuming sinc t as h1t into cos 8 pi t such that h omega becomes what? h1 of omega minus 8 pi plus h1 of omega plus 8 pi whole divided by 2. So indirectly, we are shifting that spectrum right and left by 8 pi units such that what is the range it is covering? 7 pi to 9 pi minus 9 pi to minus 7 pi with amplitude of 1 by 2. Originally 1, extra scaled by. So what is the output result? Input side, what are the numbers we have? Input side 4, 4 pi, 8 pi, but our filter is passing only 8 pi with amplitude scaling of 1 by 2. Already it is minus 1 amplitude multiplied by 1 by 2. Minus 1 by 2 sin 8. Any signal generally multiplied by cos or sin function is application of that modulation property. This is a known property for everyone, xt into cos type modulation property. Which of the given statements are true about a continuous time signal that is provided here? Which of the given statements are true? 0.4 cos 120 pi t plus 0.6 pi plus 0.7 cos 480 pi t. So, two sinusoidal frequencies are given. Option A, Nyquist rate required to sample xt is 480 Hz. Let us see. Hedge scale it is given, this is like 60 hertz, 2 pi into 60, this is like 240. We are aware Nyquist rate is 2 times highest frequency we have. What is the highest number? 240, 2 times that. True. Nyquist rate to sample that x of t is that one. Option B, it is stated that suppose xt is sampled at 200 samples per second, resulting discrete signal expression is given by this. Let us verify. T is replaced as n into ts. That fellow is saying he wants to take sampling rate of how much? 200 samples per second. So let us discuss in the next slide. Our original expression is what? 0.4 cos 120 pi t plus 0.6 pi, 0.6 pi plus 0.7 cos 480 pi t. This is the original expression given. 120 pi t plus 0.6 pi, correct. 0.7 cos 480 pi t. Okay, let us see. What is the sampling rate mentioned? 200. What is the discrete form of this one? X of NTS form. Ts is 1 over Fs. 0.4 cos of 120 pi so this is 0.4, 0.6 pi, 120 by 200. This is 2.4 pi. But we are aware discrete signal repeats for every 2 pi. Remove the internal periodicity. Remove the internal periodicity. So we got the answer as 0.4 cos of this 0.7. Cos of 0.4. But what is stated in option D? What he has stated? Oh, he changed the frequencies. 0.3 pi, 0.1 pi. What we got? 0.6 pi, 0.4 pi. Gone. If x of t is sampled at 200 samples per second, aliasing occurs. True. Why? Required Nyquist rate is 480. But if you want to choose 200 samples, definitely aliasing occurs. Required. Minimum sampling rate needed in the example is 480. Okay. That is true. The discrete signal x of n, which we obtained as the answer now, is passed through an ideal D to A converter, ideal case, ideal low pass filter type, using reconstruction rate of 200 samples per second. So from the discrete signal we want to get back continuous signal. He has given this as the continuous signal expression. Is it true or not? Let us verify that. What is the sampling rate? 200 samples per. See, T is n into Ts, that is n by 200. He has stated sampling rate as 200 Hz. Once we are using filter, ideal filter, gain is assumed to be 1 if it is not mentioned. So n equals to 200 into T to convert the discrete form to continuous form. So in the correct expression that we got, in option B, I have to replace n as a 200 T. N as 200. Okay. So that means 0.4 cos of 120 pi t plus 0.6 pi one term, 0.7 cos of 80 pi t. Let us concentrate on numbers 120 pi, 80 pi, they are given. Amplitudes 0.4, 0.7, they are also given. From the discrete signal that is available, he wants to reconstruct by using ideal DAC, D to A converter, which is like an ideal filter. We are using ideal filter. There, using reconstruction rate of 200 samples per second, he wants to recover the original analog frequency. T is n into Ts, Ts is 1 over Fs. So, in the discrete signal that is available, small n is replaced as 200 into T. We got the answer. Hope my point is clear for everyone. Sampling question. So, which are true finally? Option A, C. Okay. Area under the signal, sinc of T minus 4 by 30 is asked. Generally, area under the signal means spectrum at 0 from the definition of Fourier transform. You draw the spectrum, take its value at origin. You draw the spectrum, take its value at origin. First, concentrate on sinc T by 30 first. That is sin pi T by 30 by pi T by sin 80 by pi T. What is the spectrum? A rectangle from minus pi by 30 to pi by with extra amplitude of 30. Sin 80 by pi T. Sin 80 by pi T will have spectrum as rectangle from minus A to sin 80 by pi T. Here we have shift of 4 units. So, what is the Fourier transform? X omega. It is like e power minus j omega into T naught times this original spectrum. (30) into this exponent. Anyway, we want to check the value at origin, omega plus 0 e power j01, answer is 30. We want to check the answer at omega equals to 0. It is not continuous or discrete, all are important. Everything depends on the mood of the examiner. Certain times they will give only discrete models, certain times they will concentrate only Fourier transform chapter. This year for electrical it happened only in the first 2 chapters. It is not like that. This is also a standard model. Area under the signal means taking spectrum at origin. An input signal 2 cos 4t is passed through an LTI system having transfer function that is producing output as this. What is the value of k? Input is 2 cos 4t, that is passed through a transfer function k by s plus a. We got the output as our input frequency is 4, h of s at s equals to j4, j omega naught. that is k by j4 plus a. So, magnitude of this term is k by root a square plus 4 square. Phase angle is minus tan inverse of a plus j omega form 4 by. Input side we do not have any phase angle, but output side we got minus 45 degrees, means it is due to the system. So, minus tan inverse of 4 by a, you can say as minus 45 degrees. What is a value that will produce 45 degrees there? As the phase angle a is 4, tan inverse 1, 45 with extra negative sign. Okay. We got a, but input amplitude scaled by magnitude response is the output amplitude or not? Input amplitude 2 scaled by this magnitude response of the system is the output. So, 2 into k by input side 2 sir, root a square plus 4 square means 4 square plus 4 square equals to the output amplitude. Solve for k, 5 by 2 into root 32, that is 14.14 when you simplify. 5 divided by 2 into root 30. This is 4 root 2. After simplification 10 root 2 becomes 14.14. Input side amplitude is 2, system response magnitude response is k by root a square plus 4 square. How we got a value? Based on the phase angle. Based on the phase angle we got that result. Then you do simplification. This is also one standard model. What is the value of this integral? Integral minus infinity to infinity e power minus j pi f sinc square f. That is the question given. So, it is looking like area under the product of two different spectrums, where you can feel that as Plancherol's relation. You can solve this integral easily by Plancherol's relation. We have e power minus j pi f and sinc square f. So, you can feel this as xf, this as yf. Sinc square is Fourier transform of a symmetrical triangle. For a symmetrical triangle standard, Fourier transform is sinc square f. This exponent del of t Fourier transform is 1. What is Fourier transform of exponent term is there in frequency domain, means time domain shifting. We have exponent term in frequency domain. Del of t minus t naught means e power minus j 2 pi f t naught, that is e power minus j 2 pi f. Of course, because I want e power minus j pi f, you have to choose impulse at half. Del of t minus 1 by 2. I am choosing impulse at. So, you can feel this as yt, x of t into y of t, any term multiplied by impulse, as we are finding out area, This result is actually equivalent to what? This result is actually equivalent to del of t minus 1 by 2 into tri t. That becomes half. How? Let us see. For 1 unit width, your height is 1. I want the answer at half. 0 to 1, 1 unit width, height is 1. Here half to 1 means for half units how much? Otherwise, you find that ramp expression minus t plus 1 is the expression. Later on, substitute that instead. When you find this ramp expression, you are getting minus t plus 1. T place substitute half. 1 minus 1 by 2. Area under product of two different signals or two different spectrums means maybe application of Plancherol's relation. It is a tri t into del of t minus half. Check the value at half. That is the result. Spectrum of a signal x of t is xf equals to like a Gaussian function e power minus point f square. What is energy in x of 2t? Energy in x of 2t is nothing but energy in the scaled form. If energy in x of t is, if we are assuming like E, energy in the scaled form is E by mod alpha. E by. So let us find out energy in the spectrum using our Parseval's relation, integral mod xf square df. That is e power minus 0.5 f square whole square df. So it becomes e power minus f square, because this is nothing but what? E power minus 0.5 f square into a power m into a power n form, a power m plus n. This is a standard relation. Area under Gaussian function is root pi by a. So according to that formula, so energy in the spectrum is of course same as energy in the signal. So what is energy in x of 2t means original by 2. What is original energy? You got root pi by 2. Simplify. Okay. As time is the constraint, I am going to discuss few more examples in the revision course. Thank you.